of motion. I'm so excited.
Okay, I'm Jacob. I'm going to be your first teacher of the day.
Thank you, Jacob.
We're going over Kepler's laws of planetary motion. There are three main laws that are defined by Kepler's laws of planetary motion, and they describe the motion of the planets in our solar system. But before we get into that, I want to give some background on circles, and then Josh is going to give some background on ellipses. So this is the point. This will be the center of our circle. If you draw a circle around the point, if it was more perfect, every point on the circle is equidistant to the center. Okay?
Yes.
Now Josh is going to explain why an ellipse is a little different.
Okay, so instead of one point, an ellipse is defined by 2 points, which are called the foci. And that's plural for focus. Anyway, for an ellipse, which looks something like this, and it's kind of not to scale. For an ellipse, for every point on an ellipse, this distance between one of the foci and the point, and this distance, if you add them up, they'll always be the same. If I drew a point here, the sum of these distances will be the same as the sum of these distances.
So Kepler's first law of planetary motion, which is what we're learning today, is that each planet in the solar system orbits around the sun in an elliptical orbit, so in this shape, as with the sun as one of the foci. So the sun would be here, and then the planet would orbit in this shape.
Okay. Today from my really brilliant students, well, 2 of my former students. One, that a circle is a point with all points around it being equidistant to the middle. That's what we're talking about. In Kepler's law, we talk about having elliptical orbits, which are 2 focus pieces or 2 foci. And if you add these distances up, they're always going to be the same from this point to this point to this point. And then planets are in our solar system move in elliptical orbits, but not in circles like they originally thought by Copernicus, which you didn't tell me, but I figured that out anyway. So here it is, because I know a little bit of this. So this is actually what Kepler says, that they move in elliptical orbits, and if you pick a spot on the elliptical, those 2 points, that point is going to be the same distance, no matter where that point is, to the 2 focuses, if you add them up.
Thank you.
Yay!
Is that it?